Hello all. So let's continue our series. In this third video, we will continue where we left yesterday. Okay. So in yesterday, we have started with this notebook, and here we are going through the introduction to GCP. So first of all, we discussed what is the Google Cloud Platform. Okay, and what is the benefit of Google Cloud Platform? So we discuss it is the set of computing, networking, storage, big data, and machine learning management services. Okay. Then we saw various services provided by the GCP, like networking related, storage and database related, developer tools, and others. We uh, we uh, we see that GCP first came in 2018 with this app engines release. Okay, so it is generally used to run web applications on Google infrastructure. Then this is another picture which is showing the services provided by the GCP. So these are the compute services which is provided by the GCP. This is the networking services, then storage and databases and all these. These are the big data. Okay, and then we have machine learning. Then we discuss in detail about the GCP storage service. So these are broadly divided into four types like object, relational, non-relational, and warehouse. So we see that it is the cloud storage and then Cloud SQL, Cloud Spanner, Cloud Firestone, Cloud Bigtable, and BigQuery. Then in cloud, Google Cloud Storage, we see in details. Okay. Then we created this cloud storage bucket. We created one bucket yesterday, and we create in the US region, and then we follow these steps and complete it. We see that the storage class is basically divided as a standard, nearline, code line, and archive. And the basic difference is frequency for accessing data. So standard is like you can access data frequently. Nearline is like once a month. Then code line, if you are accessing data once a quarter. Then archive means once a year or like a long-term digital preservation. So rate also decreases as we go downward. Okay. Then we see the access control. It is like uniform and fine grained. Fine grained means we can provide object level access also. Like in any bucket for any one particular file, we want to give access, and for other files we don't want to give access. That we can also do with the help of IAM policies. Then we choose a security option and keep it default, and then we create the bucket. So this was our bucket. We see that we can upload file, upload folder, and other things we have seen there. Then we deleted that bucket because we don't want unnecessary charges. Now deployment methods on GCP. Then we see the different deployment methods on GCP. We see the compute engine, which is infrastructure as a service. Then Kubernetes engine. If we have containerized applications, then we can use it. It is hybrid. Then we see app engine. Uh, uh, so then we see cloud functions means if we have any small query or a small code, then we can deploy on cloud as a function. This app engine is platform as a service. Then we discuss about Google Compute Engine in details. Like these are the self-managed virtual machines which have their separate uh, operating system, and you can select CPU memory as per your requirement. Okay, so here it is the diagram. So we have virtual machines which have separate apps and OS. Okay, then here also, and there is virtual hardware for every machine, and the software which is uh, mhm. Virtual machines run on physical machine and access computing resources from software, which is known as hypervisor. Okay, so for accessing resources from this Google infrastructure, we use software known as hypervisor. Then we see Google Kubernetes engine. Kubernetes are also known as K8 ACE, is an open source system for automating deployment, scaling, and management of containerized applications. Kubernetes is a portable, extensible, and open source platform for managing containerized workloads. Containers are similar to virtual machines. We have discussed that containers are similar to virtual machines, but they are relaxed in isolation properties. Like they can share virtual means these containerized applications can share operating system. Okay, so this is why these are lightweight uh, containerized application. Okay, compared to virtual machines. And then we discuss why you need Kubernetes. Then come the Google App Engine. So we discuss about this app engine. This is a service for developing and hosting web applications and Google data centers. So this belongs to platform as a service category. Web applications hosted on GAE are sandboxed. Yes, and run across multiple servers for redundancy. So these are some qualities. And what we study about the advantages of Google Kubernetes, Google App Engine. Okay, so it allows you to build application on the same stable extendable platform which has support facility of Google large number of applications. So these are the same platform on which other applications of Google are running. So these are some benefits. App Engine language Java and Python are easy to understand and implement. Then we see the cloud function, Google Cloud function. With cloud function, there are no severe to provision, manage, patch, or update. Okay, so functions automatically scale and are highly available and fault tolerant. So these are like automatically scalable and highly available and fault tolerant. Cloud functions are great for building serverless backends. Okay, function is an independent unit of deployment as a microservice. So they are like a microservice. It's merely code deploy in the cloud and is most often written to perform a single job, such as saving a user to the database, processing a file in the database. So these small operations can be done using this cloud functions, performing a scheduled task. So now we discuss which method should we choose. On the level of abstraction, we can decide. Okay, so this we have seen yesterday itself. Now, today we will start with uh, creating a compute engine instance. So today We will start with the compute engine instance. So for this, we need to go here, and in this, we will go here like compute engine. Okay, then in compute engine, there is one option, virtual uh, VM instances. Okay, so we will click on this VM instances. So it will show all the virtual machines. So one virtual machine instance is already there. This I have developed for our Amex American Express use case, which I did in live coding part one. Okay, so I created this virtual machine instance because when I I was running that code in my Colab, so RAM was not sufficient. So I created this VM instance there. Okay, so for now I have stopped it. So if you will see that the machine type is E2 standard 8. Okay, and here in Colab we generally I think we get uh, 12 GB of memory, but I required more memory. So here you can see I have taken 32 GB of memory. E2 standard 8 and 32 GB of memory. Okay, so this is the instance which I was using. So for now, uh, in this tutorial, we are creating a new instance. So for this, we will create on this create instance. So now here we have a machine configuration. So this is the name of instance. The name must start with a lowercase letter followed by up to 62 lowercase letter numbers or hyphens and cannot end with a hyphen. So this name should not end with hyphen. What should be the rules while giving this name is written here. So you can provide your name. Okay. Then we reason we have selected US Central One Iowa. Okay. And zone. Uh, then now Now, machine type for common workloads. Optimize work for cost and flexibility. So these are the machine types for common workloads. This in this we have general purpose machine type. We have C4. This is and here we have description. Then values represent the range of CPUs available for this. So how much CPUs are available, and this is the memory. Okay, so and this is the CPU platform. So it is C4 uh, for consistently high performance. 2 to 288 CPUs are there, and this much is the memory. Then we have C4A, then C4D, consistently high performance, and CPU's range will be here. So after that, you can select from here. Okay. So these are the details. Now we have selected a low cost and day-to-day computing. So here CPUs will be up to 32 and memory will be 1 to 128 GB. Choose a machine type with a preset amount of CPUs and memory that suit most workloads. Or you can create a custom machine for your workload particular needs. Okay, so this is the preset, and you can create custom also. So how many cores are required, or core should be shared, and how much memory is required, provision model. Okay, so you can customize also. We will see the preset. So it is E2 medium. Two CPUs are there with one core and 4 GB of memory. Okay, so this is the standard. It is E2 micro and E2 small. And this is the standard. This is high memory. If you take this here, see cost is improved. Sorry, increased. Okay, so like high CPU, two CPU with two 32 CPUs with 16 core and 32 GB of memory. See how this rate has increased. Okay, so we will go through this only. Also here, if you want GPU, so here it since I have free trial program, so we cannot add GPU. But here see different NVIDIA L4 is there, NVIDIA T4 is there, NVIDIA V100 is there, NVIDIA Tesla P4, Tesla P100 and RTX Pro 600. Different types of GPU is there. So since we have this trial account, so we cannot take GPU for now. So just go to a general purpose and everything is okay. And then we will uh, and unique name is already selected. So we will now we check the OS and storage. In OS and storage, you can select for your virtual machine what should be the OS. Okay, so here it is Debian. Okay, Linux 30. This container is deprecated. The option to deploy container or VMs during VM creation is deprecated. So during creation of VM, previously we can deploy containers also on our VM, but this option is deprecated now. So here, if we want to change it, so in operating system, uh, we have Debian, Central OS, Container Optimized OS, Deep Learning on Linux, okay, and Oracle Linux, Red Hat, Rocky Linux, Ubuntu is there, Okay, so we will use Ubuntu only. So these are the options. So select Ubuntu, and in Ubuntu, we will select like different options are there. So this part you can select by yourself. Okay, like Ubuntu, like this one I can use. So size also we can select. So this is the this standard is sensitive throughput, optimized non-boot data drives. Okay, and this is balanced. This is SSD, and these are the compared. So select this one. Take it balanced. Okay, then select it. Okay. Now see, it has not changed much here. If we will select Windows here, na, then you will see that it will be changed a lot. Then we go to data protection. In data protection, you can automate recurring backup through a backup plan or a snapshot schedule. Backup plan means or a snapshot schedule. Backup disk only. So this will backup disk only. This provides fundamental protection at a lower cost. So the whatever is there on your disk that will be backed up. Okay, and backup the full virtual machine. So it will backup the complete. The immutable backups are secured by a backup vault against accidental or malicious deletion. Managed by backup and DR service. A separate service from compute engine with independent certifications uh, and accredi- accreditations. So they have selected this backup for now. Uh, you can select this also. Uh, Now replication. Use synchronous replication. Switch to regional disk, which is single disk with storage replicas in two zones. Enables zero R RPO, no data loss, and VM attachment in two zones. Use asynchronous replication. Exclude boot disk from data replication. So these are the data protection options. We keep it same. Then networking. So select a firewall rules to allow specific net traffic from the internet. So what should be the firewall's rule? Firewall rules will only be applied when instance is created. So here we will uh, we will allow HTTP traffic and allow HTTP uh, as traffic. Okay, uh, and allow load balancer head check. So let it be unchecked only. IP forwarding is like let it be this only. Then network bandwidth enable per virtual machine tier 1 networking performance. So maximum outbound network width is like 2 Gbps. Okay, so we will not change this. Then observability. Uh, Ops agent recommended. Observe your instance and replication through collection of logs and metrics. Install Ops agent for monitoring and logging. Display a device. Enable a display device. Okay, and then security. Identify and API access. So this is the security. We will let it be default only, and then uh, we will click on this create. So when we will click on this create, you see this instance will be created. Okay, so now this instance is created. You can see that in my older instance, external IP is not showing because right now I have stopped my this VM because I am not using it, so I have stopped it. Okay, so but now since this is the newly created instance, so you can see that external IP is showing. Now this is the SSH. So this SSH or secure cell, it is like cryptographic network protocol used for securely accessing and managing remote machines over a potential unsecured network. Uh, Actually, it provides a secure way to log into remote server, and if we want to execute commands and transfer file between computers. Okay. Uh, this SSH is like widely used in various contexts, including virtual machine instances. SSH allows you to remotely connect to and manage virtual machines operating system. So this allows you to remotely connect to and manage the virtual machine operating systems. Now click on SSH. It will it will open a pop-up window that will lead us to the console of created virtual machine. So if you will click on it, so one pop-up window will be opened, and this will lead us to the console of created virtual machine. So console of virtual machine, we can access it. Now you can see it. After SSH connection is made, your console will look like this. Okay. Uh, this will showcase all the details of your virtual machines instance, like the type of connection, memory used, swap usage, and IP address, etc. Okay. So uh, your instance name along with your account name will displayed as the console environment. To check whether our VM instance running actively, let perform a single simple task of getting a list of VM created. Okay, so before we run the command, we will authenticate our GCP account to in order to access the project in which VM is created. Uh, we will run this simple authentication code. Uh, this what it will do. This will provide a link for an authentication code. We will simply paste that link in the browser and add the authentication code in order to access current project. So we will copy this link, paste in the browser, open this link, click on continue, allow, and copy this and paste it here. Okay, so that so that we can access our current project. After you put the code, you will by default be in the project you are working on. Okay, and if you want to change the project, you can do that as well. Uh, now here you can see you are now logged in as Rahul dot Saraswat 2026 at the rate gmail.com. Your current project is second project, and this one. Uh, and here also you can see this is the same project. Okay. Uh, you can change this setting by running gcloud config set project and then project ID. So if you want to set any other project, you can do that as well. Now simply run. run this. We will run this code to get a list of VM created, and there you have it a functioning instance. Okay, so G Cloud compute instances and list. So it will show the all the virtual machines. So two instances are there. For one which is stop external IP is not showing. It is showing status as terminated and running. You can monitor the working of your VM from observability tab. So here we have observe of this tab observability. From this we can monitor the working of our VM. Okay, which gives you an option to keep an eye on the traffic, memory, process, and disk usage. So here you can see CPU utilization, top 5 VMs, memory utilization. So in this way, you can see for our VM, you can monitor. Uh, Now, see, this will charge a lot for us, and we don't need it for now. So what we need to do to avoid unnecessary charges of running an active VM, it's important to clean up your project if you are not going to use it further. Okay. Sim for if how you can delete it, just simply select your VM uh, and click on delete. So here you can see that stop, suspended, reset option is there. Here you can see that this delete option is available. So we will create on this delete. So uh, it is asking delete instance this. Are you sure you want to delete instance? This will delete a boot disk instance. This VM will shut down. If processes are still running, the VM will be forced to stop prior to deletion and files may get corrupted. So this is the thing. Now click on delete. So this instance will be deleted. Uh, okay, it will take some time. Here, here these are the different options in virtual machines like instance template, sole tenant node, machine images, TPUs, committed use discounts, reservations. Okay, it is deleted now. Okay, and in storage we have disk storage pools, snapshots, images, async replication, consistency groups. instance group, health check. Okay, so these are the things. Then we have bare metal solution, servers, networks. Okay, all these. And in the last, we have marketplace also. So we can explore different virtual machine solutions in the marketplace here. So if we will click here, uh, we can explore uh, here. We can find third-party tools, custom images, databases that we can integrate with our VM. So like Gen, Gen, generate motion, device image, then databases, PostgreSQL, Armored by SD, operating system Debian 10, Ubuntu, and other Windows Server 2019 for networking are there. Okay, and you can see for networking, 318 options are there here, 322 option databases, 10 databases are there. So like this, you can explore in this marketplace. Okay, so let's proceed further now. Okay, so now uh, create compute in an instance. So create or select your project and navigate to the VM instance in the cloud, Google Cloud Console. So we need to click here. We have already done this. I'm just going to notebook. Click on Cloud Compute, then on VM instance. Click Create Instance to start with creating the VM instance. So we need to click on this Create Instance button. You can choose how you want to create the image. That is, you want to create from a template machine image or a marketplace. Okay, so now these are the options. Now it has changed. We have seen. So here we can provide the name. What should be the region? Then machine configuration. We can select like general purpose, compute optimized, memory optimized, GPU. And as per our selection, this rate will be changed. Uh, So we have selected E2 and E2 medium, two CPUs and 4 GB of RAM. Then these are the rules for creating a unique name for your instance. And these were the naming convention. Okay. Now we need to choose a region for our VM. So these regions are the permanent configuration for our VM. It cannot be changed. If once the VM will be created, this region cannot be changed. Now we select the machine configuration for our VM. Here we are selecting general purpose small instance that comes with single core and 2 GB RAM. Go through the link to understand more types of compute instances and their pricing. We have already seen this pricing. So we have selected this one. You can click on enable display. So where is that option enable display? Okay, so you can click on enable display if you want to record your screen. As we do not need that now, so we will leave it. Okay, if you want to deploy a container on your instance, you can do that as well. So we have seen that that container option is this option is deprecated now. Checkout setting provided on that specific section. Now comes the boot disk part. Here we select type and size of the instance. The default type is Debian image with 10 GB disk. So default was Debian with 10 GB. We will change our type of image to Ubuntu for a bit more familiarity with the console. So we selected Ubuntu 20.04 LTS. In the identity and API access, we choose the billing account where all the APIs are enabled. The identity and API access select. The identity and API access select allow full access to all cloud APIs. Okay. In firewall section to permit HTTP or HTTPS traffic to the VM. Allow HTTP traffic or allow HTTPS traffic. When you select one of these, Compute Engine adds a network tag to your VM, which associate the firewall rules with the VM. So finally, click on create and wait for a few minutes. You can see an estimate cost of running. So in the right hand side, you can see the estimate cost of running this instance. So for us, it was 25 point something dollar. Uh, you can adjust your settings accordingly. So like, so we have created our instance. Um, then we use SSH or secure shell, and it is like cryptographic network protocol, uh, which is used for securely accessing and managing remote machines over a potential unsecured network. It provides a secure way to log into a remote server and execute commands and transfer files between computers. SSH is widely used in various contexts, including virtual machines instances. SSH allows you to remotely connect to and manage virtual machines operating system. Click on SSH, it will open a pop-up window that will lead us to the console of created virtual machine. Okay, so when we click on this SSH, it will open a pop-up window that will lead us to the console of created virtual machine. After the SSH connection is made, your console will look something like this. So when SSH is connected, console was looking like this. This will showcase uh, details of your VM instances like type of connection, memory use, swap usage, IP address, etc. Okay, so now before we run the command, we will authenticate our GCP account. So in order to access the project in which the VM is created, we will run simple authentication code. That is gcloud auth login. Then this produces one link. We go to that link and here, and then we paste that link here. After you put the code, you will be you will by default be in the project you are working on. If you want to change the project, you can do that as well. So if you want to change the project, you can do as well. And now simply run the code for getting the list of VMs created, and there you have it a functioning instance. So by running the code gcloud compute instances list, you can see all the instances. You can monitor the working of your machine. This also we have seen, and then we do cleanup like we deleted our virtual machines instance. Also, we see that on the left hand side we have option marketplace. Here we can find third-party tools, custom images, databases that can be integrated with our virtual machines. Okay, so these are the different options. AI/ML on GCP. Now come our next section, that is AI/ML on GCP. Uh, the most compelling advantages of AI cloud are the challenges it addresses. Google Cloud AI tools are armed with best of Google research and technology to help developers focus exclusively on solving problems that matters. So you no need to worry about different things that Google will take care, and you can focus exclusively on solving problems that matter to you. Now, cloud AI platform. Google AI platform is a one-stop solution for machine learning developers and data scientists to take their ML projects from experiment to production and deployment. So, this Google AI platform is one-stop solution for machine learning developers and data scientists. Here, from experiment to production and deployment, we can do. From means end to end, we can perform here. AI platform integrated with several easy to use tools that help us build and run our own machine learning applications quickly. AI platform tools can be used in these tools which are provided by Google can be used in train an ML model on your data. So you can train an ML model, train model, evaluate model accuracy, tune hyperparameters. We can do hyperparameter tuning. We can deploy our train model. We will do one case also, like we will deploy one model also, then send prediction request to our model. We can do a prediction request in two ways. Like one is online prediction and another is batch prediction. And batch prediction is available for TensorFlow only. Like we are doing weekly sales forecasting. So that is or fault means credit card fault detection case. So in for that we don't need to run continuously. Okay. But we online prediction is like if we are doing any means recommendation system. So at the same time we need to do, and here we can do in batches at recurrent interval like hourly or daily basis. Monitor the predictions on a ongoing basis. Okay, then we monitor the predictions also, and we can manage our models and model versions also. So this monitoring data drift, वगैरह, drift, uh, all things we will see. Now see the auto ML. So cloud auto MLs enables developer with limited machine learning and programming expertise to train high quality models specific to their business needs. So this is one option which is provided by the Google Auto ML. In this, uh, you don't need to have like any expert in machine learning and programming. Uh, this service leverages Google's research technology and also relies on Google state-of-art transfer learning and neural architecture search technology to achieve faster performance and more accurate prediction. People can train, evaluate, improve, and deploy. People can train, evaluate, improve, and deploy custom machine learning models to solve problems for vision, translation, and natural language, which is already provided by Google. By using a simple graphic user interface with few menus. Okay, so like in the few menus, we can train, evaluate, improve, and deploy custom machine learning models. So how AutoML works? So we have dataset, then we have AutoML. In this, we can train, deploy, and serve, and we can generate predictions with the help of REST API. So Google Cloud Vision. So this is the AutoML service which is provided by the Google. It has two different services, Vision API and AutoML Vision. Vision API can be used to detect objects and faces, uh, read printed and handwritten text, and build valuable metadata in your image catalog. AutoML Vision can be used to automate the training of your own custom machine learning models. So, this AutoML Vision can be used to automate the training of your own custom machine learning models. Uh, GCP AutoML Text. It is an AutoML service that is used to analyze the text to find sentiments, knowledge entities, and topics categories associated with the text. Then GCP Tabular AutoML. It is used to analyze the content of tabular data. It provides regression and classification models to extract numerical data from tabular document and classify the document into different categories. So this GCP Tabular AutoML, it is used to analyze the content of tab. If our data is tabular, then we use this Tabular AutoML. It provides regression and classification models to extract numerical data from the tabular document, okay, and classify the document into different categories. In addition, if data present in tabular form is time series data, okay, so if our data is time series data, it also provides a forecasting model for predicting a series of numerical values. So if our data is time series data, so it also provides forecasting model also. Mm, AI infrastructure tools, deep learning containers, GCP provides configured and optimized containers for deep learning environment. So this GCP provides configured and optimized containers for deep learning environments. Deep learning VM image, pre-configured virtual machines for deep learning applications. So these are deep learning virtual machine images. Now we have GPUs. GCP provides high performance GPUs for machine learning, scientific computing, and 3D visualization. Now come the Vertex AI. Okay, so Vertex AI brings AutoML and AI platform together into a unified API. So this Vertex AI brings together agentic AI also in this. Okay, we will see later because we are going to work on this Vertex AI in detail. Okay. So Vertex AI brings AutoML and AI platform together into a unified API, client library, and user interface. With Vertex AI, both AutoML training and custom training are available options. So in Vertex AI, we can do AutoML training and custom training both. Vertex AI Vertex AI provides you all required Google Cloud service in one place to deploy and maintain AI models. So, what is the benefit of Vertex AI? It provides all required Google Cloud services in one place. Considering it as a managed platform, it automates things for you and lets you focus on more important things in machine learning workflow. So it Vertex AI manage a platform and it automates things for us and make us focus on our on more important things in machine learning workflow. Uh, the Vertex AI platform boasts tools that help with everything uh, from the beginning stage of data collection to analysis, validation, transformation, model training, evaluation, serving the model, and metadata training. So everything is available in Vertex AI, like um, data collection, analysis, validation, transformation, model training, and all. Using Vertex AI not not only simplifies the initial development process, but streamlines the iteration process and as the model is adjusted over time. By using Vertex AI in combination with other Google offerings like AutoML, companies can effectively build working ML projects without data science experience. Vertex AI provides unified definition implementation of following steps. A dataset can be structured or unstructured. It has managed metadata, including annotations, and can be stored anywhere on GCP. Okay, a training pipeline is a series of containerized steps. Uh, so the training pipeline is a series of containerized steps that can be used to train an ML model using a dataset. And endpoint can be invoked by user for online predictions and explanations. So here we have ingestion, analysis, then data transformation, training, tracking and ML ops, then evaluation and deployment also. Okay, so in deployments and batch predictions on Anthos and on cloud. A machine learning workflow is a long process where different platforms are involved. Okay, so this machine learning workflow is a long process where different platforms are involved. However, Vertex AI comes up with a unified API and UI with access to all the Google Cloud services. So we don't need to go to for different platforms. Here we have everything at the same uh, at the one place. You can simply train AI models with custom code training and store them in a single repository. So you can simply train AI models with custom code training and store them in a single repository. Additional, they can be deployed to the same endpoints. Infusion of vision, translation, natural language, and a video in ML will be an easy task in pre-trained with pre-trained APIs available in Vertex AI. So what are the benefits of Vertex AI? Machine learning developers don't necessarily have to be programming expert as the managed platform involves 80% fewer line codes. On the other hand, pre-trained APIs make the job easier for development of AI devices. Competition platforms and custom libraries uh, allow businesses to design a high-class machine learning devices. In support of that, advanced ML coding also works for the same field. Okay, with ML of tool like Vertex AI, Vertex ML metadata, AI pipelines, and Vertex model monitoring, you can manage the ML workflow easily here. Okay, means ML of part also can be done here. These tools remove the complexity of repeatability and self-service maintenance. We are very familiar uh, with working in. So this is the property of production journey. So this is the complete production journey. We will do this with the detailed use cases. Okay. We are very familiar with working in notebooks, and when it comes to building a model, Vertex AI also provide notebook console and other options also. So just a second, 1 minute. Now, Vertex AI Workbench offers a managed notebooks options with built-in integrations that help you to set up an end-to-end notebook-based production environment. So, Vertex AI Workbench offers us a managed notebooks option with built-in integrations that help us to set up an end-to-end notebook-based production environment for users who need full control over their environment. Vertex AI Workbench provides a user-managed notebooks options also. Both notebook options are pre-packaged with Jupyter Lab and have a pre-installed suite of deep learning packages, including support for TensorFlow and PyTorch frameworks. So like uh, all the required suites are supported here. You can use CPU only or GPU enabled instances as per your requirement. Vertex AI Workbench Notebook instance also integrate with GitHub. So this Vertex AI Workbench can also be integrated with GitHub so that you can sync your notebook with a GitHub repository also, creating a Vertex AI Workbench notebook. So here they are creating a Vertex AI Workbench notebook. Under a new or same project, search for Vertex AI in your console and navigate to the Workbench section. Okay, so here now you will not see this Vertex AI option because it is renamed now. Okay, so here now it is Vertex AI is named as Agent Platform. Now in this Vertex AI, click on this agent platform. So here you have you you can navigate to this notebook option. Now click on create a new notebook under and you will Okay, so these are the click on the workbench. Okay, now in the manage notebooks, and these will be, I think, deprecated. Okay, so this option, so this is deprecated. Okay, and manage notebooks and user manage notebooks, these both are deprecated now. So we have this instances option available. So for in this, you don't have any instances in this project yet. Okay, so in this, you just need to click on create new. Here, you can mention the name, then region, and if you want to attach NVIDIA T4, eh, and if you want to enable Apache Spark and BigQuery kernels network in this project. Okay, and a sub network also you can mention. Machine type will be E2 standard 4. Data disk 100 GB balanced persistent. Jupyter Lab version 4 will be there, and permission compute engine default service account. Okay, so now if you will click on this create, then new Jupyter Lab notebook will be created. So I just created on this. So if you want to learn more about this, you can read here also. Gemini Enterprises agent platform purpose are Jupyter notebook based agent platform workbench instances are Jupyter notebook based developer environments for the entire data science workflow. You can interact with Gemini Enterprise agent platforms and other Google Cloud services from within a agent platform workbench instance Jupyter notebook. Agent platform workbench integrations and features can make it easier to access your data, process data faster, and schedule notebook runs and more. Okay, so how you can access to data? You can access your data without leaving the Jupyter Lab user instance. In Jupyter Lab, navigate menu on a agent platform workbench instance. You can use the cloud storage integration to browse data and other files that you have access to. So it's creating now. It is taking some time. You can also use BigQuery integration to browse tables that you have access to. Okay, so you if you will click on this, access cloud storage buckets and files in Jupyter Lab in a agent platform virtual instance. So this page show you how to mount a cloud storage bucket to the Jupyter Lab interface in your Gemini Enterprise agent platform workbench instance. So you can browse the file that are stored in cloud storage. You can also open and edit files that are compatible with Jupyter Lab, such as text files and notebooks. So in Google Cloud Console and on the project section page, select or create Um, a Google Cloud project. Roles required to select, okay, the project we have already created. Enable the notebooks APIs. So these are the roles like notebooks runner and storage object user. So required permissions for enabling shared storage mounting. To enable shared storage mounting in your agent platform workbench instance, ask your administrator to grant your agent platform workbench instance service account the storage bucket list permission on the project. The storage buckets list permission is required for the mount shared storage button to appear in the Jupyter Lab interface of your agent platform workbench instance. Now create a bucket and the agent platform workbench instance. You must have at least one cloud storage bucket in the same project as your agent platform workbench instance. If you need to create a cloud storage bucket, you can see here. If you haven't already, create an agent platform workbench instance, which we have created here. It is creating. Now open Jupyter Lab in the Google Cloud Console. Go to Instances page. Go to Instance. Next to your agent platform workbench instance, and click Open Jupyter Lab. So here now it is created. So you need to click on Open Jupyter Lab. Okay. Mount the cloud storage bucket. Then you need to mount the cloud storage bucket. To mount and then access the cloud storage bucket, do the following. In Jupyter Lab, make sure the file browser tab is selected. Uh, in the left sidebar, click the mount shared storage button. If you don't see the button, drag the right side of the sidebar to expand the sidebar until you see the button. In the bucket name field, enter the cloud storage bucket name that you want to mount. Click on mount. Okay. And your cloud storage bucket appears as the folder in the file browser tab of the left sidebar. A double click on the folder to open it and browse the content. So just click on open Jupyter Lab. This will open Jupyter Lab. You can see other options are also there. One error is showing. A cloud storage a browser has the file system context. To create a notebook in your local file system, So the file system content by selecting a folder in the file browser. So here you can see your storage is showing. Okay. So in the bucket name field, uh, enter the Cloudwell bucket name and you want to mount. Click mount. Copy this name. Uh, then click here. Mount share storage. Copy this name and then click mount. Okay, so it is mounted now. So, okay. Now if we click here, uh, this is open. Okay. So if we run this, okay. So now we want to read this data. So we will copy path. Okay, so you can see we can read this data from here. So this is the this is our workbench instance. Okay, so just for now, click now. So like this, we can do. Okay, so like this we can create. So it takes 5 minutes when the open Jupyter button turns blue. You are good to go and get on coding. Vertex AI gives you a lot of options and built-in uh, options and multi-kernel support to set working environment for you. Uh, uh, you can also pip install additional libraries that are included by default. Okay. So you can also pip install additional libraries that are not included. Okay, so like this we can do. So now what's the conclusion? Different analytics and technology companies, just a second. Different analytics and technologies companies predict future AI usage in different industries and different use cases. Cloud delivery and cloud computing methods will help much to shape to use of AI use case effectively. When it comes to machine learning devices, Vertex AI has infused a new life. Okay, the unified platform has shown the bright future of machine learning and why it is considered as must-have for business worldwide. So this is the all. In the next video, we will proceed in this and we will train one model on the Vertex AI and then we will deploy a model. Okay, and then we will create Kubeflow pipeline and also model monitoring we will do. So it will take some videos, but this is all for now. Thank you.